Genghis Khan, Napoleon, and Albert Einstein all had one. I've got one, and probably some of you have one too, a prostate. And just like how every human being is a unique individual, every prostate is unique as well. But what exactly sets one prostate apart from another? Why do some prostates develop prostate cancer? Why is it that some prostate cancers become aggressive, life-threatening conditions? Or develop resistance to treatment? Or relapse after seemingly being cured? Decades of research have shaped the way we diagnose and treat cancer, but we still don't fully understand how cancer works. To answer these questions, we need a better understanding of what exactly makes cancer cells behave the way they do. And for that, we need more prostates to study. But getting your hands on fresh prostate tissue to study is a lot easier said than done. For one thing, the prostate sits in a rather intimate and inaccessible part of the human body. Besides that, most people get pretty squeamish just at the mere mention of getting a prostate exam. Since I can't get my hands on fresh whole prostates to study, I'll be growing my own. And I'm not talking about the one in my pants. I'll be using cells taken from prostate cancer patients during routine diagnosis and testing procedures that otherwise would have been incinerated and thrown out. By using these cells and growing them inside of a gel matrix, or a scaffold made out of the same materials you find in the human body, I can recreate the environmental conditions you might find inside of a real prostate. Cells are able to grow and organize themselves in 3 dimensions, and eventually they form these balls of prostate tissue. And while they're a lot more simple than real prostate tissue, we can use them to model how prostate cancer cells behave under certain circumstances. The goal of my research is to understand the interactions that cancer cells have with each other and with their environment. I'm especially interested in how cancer cells respond to different kinds of environments. And I can make these environments just by changing up the overall mix of materials I use in my gels. By doing this, I can create a wide array of different prostate cancer tissues. And by studying them all, I hope to get a better understanding of how prostate cancer cells behave in real prostates, in real life. This kind of information would be important in developing new, improved, personalized treatment plans for prostate cancer patients, and can also help identify those of us who are most at risk at developing more aggressive forms of this disease, saving lives one unique prostate at a time.